HBase store one demographic records. Demographic records. Okay. Now in this demographic, we have some personal and private information, right? If I'm storing this data in RDBMS, then how would it work there? Or how we create any table structure or a schema? We say create table first, then we start writing the information. We know already the SQL or any database part, how the data is getting inserted. Now in this HBase, I will store my data in this form. So here we will have row key, row key. Then we'll have column family. So structure is as follows. In HBase, we do not have any primary key. Remember this. HBase does not support the concept of primary key, unique key, foreign key, reference key. Okay, we do not have this primary key here. Second, the structure of column will be column family. I'll tell you what is a column family. Column name. Column family, column name. This is our column name. Sometimes this is also referred as a column identifier. Column identifier. We'll see this example. This is a structure example in this demographic result. Now I want to store one record as personal. Okay. So demographic of person, if I say, and that is a personal record, which means bank account number, credit card name number, debit card name number, those can be a personal record. Then second is a professional, I can say, or public record also I can say. So personal and public, just to make it simple. In public, we have name, age, designation, salary, and such information. Now I want to use the column family and column identifier concept here. So row key is there, and this two name. So I'm trying to give one graphical representation, and then we'll go and see the query part. Row key, personal, then second is a public. Now this personal is a column family. I will create a column name or column identifier. So in personal, I give a name of, say, a bank. What's the bank name? What is the credit card number? Okay, maybe what's the PIN code? Public is having name, then second age, city, company name. Let's say we have this 4 information. Okay, so I'll create one structure to create this column family and column identifier. Now time to insert the record. Instead of primary key, the same job is done by the row key. Okay, so whatever your primary key is doing, the same job can be done by this row key also. Record, if I insert, I'll say here. And by the way, I can write any information here, right? Because this is not following any structure order or any schema order. In single column, I can store string, integer, float, double, boolean, any types of data. We've seen already that. So row key will store R1. I'm using just this R for to represent the row. However, if you're thinking that can I write 100,000, I can do this also to store any record in this. So R1 I'm giving for to remember this is a row key data. Now this row key is associated with this entire row result. This row key is associated with entire row result. So suppose bank name is SBI, credit card number is 5732, pin code we have some, name is Abhi. Suppose age is not known to me. Okay, if I do not know any result, by default it will not keep here null. Remember, if you're not giving any result for any column identifier, unlike RDBMS, what RDBMS does, RDBMS will keep null result if you're not declaring as not null to your DDL time, column creation time. Here, if I do not pass anything, it is empty record. And I don't know the age currently. Okay, city is Indore, company is Xerox. This R1 is associated with 1% result. Similarly, then I will have R2, another row key. Bank is, let's say, I don't know the bank name this time. Credit card number, I know 52559. Name is George, age 29, Trichy, working with TCS. And likewise, I have result stored. Multiple rows I have, okay? Let's say one more row I will take, R3. Here I have the complete result. I know the bank name also. I know credit card number. I know PIN code. I know their name, age, city, and company. Okay. Now, data is inserted when you're running a query. So here you'll see why RDBMS query is faster than, NoSQL query is faster than RDBMS. So I'm searching for a result. Let's say I'm searching for a result of this name. That what is the name of row key, because your every search will work based on this key only, because this is working here as a primary key. So if you're searching for this result, which is George, what this George query will do. So a query I'm not writing here because syntax we have not yet seen. So when we know the syntax, I will write the query that time. Currently just logic we are understanding. So if I'm searching for this George, what your HBase does internally, HBase is not scanning the entire row. What HBase does, HBase says, okay, R2 is a key which I'm looking for, and then it will check which column family. So you'll refer that this George is a part of name and name is a part of public column family. It will not even touch this column family. So obviously if it is not touching this column family, it's not even going to this column family and checking the result and immediately bringing this record in your console. So scanning here is happening vertically. If I'm looking for name, it checks this name for this row key. So scanning will work like this. It will check this row key first and this name. So automatically they find this result. Now, if I have 1,000 of column or 10,000 of different dimensions means column only. So they will not check other 9,999 dimensions. They will check the one which is required by my table and immediately bring that result. So scanning is happening here vertically. If the same result is in RDBMS, what they do, they will check the entire row. So if you have n number of column, they will check all the n columns. Suppose 100 is the column number, they will check all 100 columns. And this is why useful in machine learning in Hadoop, because currently we are not talking about data dimension of one column, 10 column, 20 column. Those are RDBMS days. Okay, when we have 100 column, we say this is huge number of column we are having in table. When we process image kind of data, okay, just being one scenario, when we are in machine learning, we process image, right? So this image size itself is having sometime here we have seen 70,000 dimension also. So when I say dimension, I'm talking in math term. I'll say this is my column name. Dimension I'm referring as a column. So in machine learning, we call it a dimension. So I'm using the same term. So if this is an image, okay, this is some person image or some digit scanned image. It will generate me 70,000 columns. Maximum I'm saying, which I have dealt with so far. But if it is even your passport size of data also, vertically their pixel 28 and horizontal their pixel is also 28. So if you are creating a data point using this 28 by 28, you can calculate this. So 28 into 8 is supposed to 4 and carry forward 28 to 50, 70, 74. 74 columns will have, okay, just for passport size of images. So we are not storing this information in any RDBMS. If I give you example of UIDI, User Identification Authority of India, UIDI, Authority of India, Data Authority of India, right? Aadhaar card. So this data, they're not storing in RDBMS. If you think this data is getting stored in RDBMS because the total population is 1.3 billion, if they store this 1.3 billion result in any RDBMS, first thing, I'm not sure whether RDBMS can handle it or not. If they can store it also, query cannot be scaled. Query cannot be scalable. So that is the challenge here. Okay. So though this is also RDBMS is a transactional data, right? Works with the OLTP, online transactional processing. But my NoSQL is even more low latency type of information. So whenever I'm receiving any data from web server using Kafka, using Kinesis, okay, using Polar, there are many other tools available. Okay, JMS, Java Messaging Services. So there are so many messaging queuing available, which takes the data from one location, write it to another location. We have the Kafka and other part in our upcoming module, but when to use this low latency, that's important. Always remember near real time data. And if it is a structure, semi-structure, unstructured, I can do that. So this is how the searching will happen. This is your data will look like. Now let's go and create this data, create this table and see the query, how to create, how to insert, how to update, how to delete. Then if you have any question that I want to search for this, maybe I want to search for this, or I want data in between this two value, all that filter operation you can work with any NoSQL tool. Only one limitation we have there, that they cannot perform joining. So I can write that as a limitation part. HBase does not support joining. HBase does not support joining. We cannot join two different tables because it is not working in a form of DDL, DML, DRL. It is storing all the data in a cell types. So just like in Excel, we have a cell A, cell B, cell C, then we are having column wise cell, row wise cell. This is exactly the same thing. Internally, they're storing data in a cell wise only. And HBase is built on the combination of the cell is built on the combination of JRuby, Java plus Ruby. And to open any HBase cell, we go to terminal when type hbase space hyphen cell. And before doing this, you always check using JPS that your master, your reason server, your uh, quorum peer main, which is a service of Zookeeper, is all up or not. If all is up, then only start with the cell. Once you type this, you go inside this HBase, and then you can start running your query. So we'll see the benefit first, how to create the table or how to list their database. So we do not call database in HBase, we call them namespace. List namespace. This new name you're saying, and you relate this namespace with your database. So I'll in bracket I will write this is DB. Okay. What query will write in the cell HBase? List underscore name space. So this is the DB. Let me write a query here, and then maybe I'm running here in this system. Go to HBase cell. Query is very different from RDBMS. Okay, so do not relate your RDBMS query. One session for Cassandra also I will take. Cassandra, if you know HBase, Cassandra 80% thing we already know, their logic, the communication, the protocol. Only the syntax is, Cassandra syntax is very similar as SQL. So people who know SQL syntax, they can easily get Cassandra concept, especially the syntax. So list underscore namespace. If I type this displays me how many uh, database are present. Okay, so interchangeably I can use it, but in HBase I want to use namespace. So please remember that going forward, whenever we discuss HBase concept, I will not say database, I'll say it's a namespace. Now, if you want to create a new namespace, right? So what you'll say, create underscore namespace, and then namespace name. Let's give this namespace name as HD. Okay, created. Then again, list underscore namespace, that HD is created. So write it here, how to create the namespace. HBase create underscore namespace, and then your namespace name. Currently I gave this as HD. Now if you see all this result, I'll be storing in form of JSON. All this I'll be storing in form of JSON. Okay, and when I open this HBase cell, it's not giving me here that jrupee command, but yeah, I can check that from my HBase site.xml that this cell is built on the concept of jrupee, Java plus rupee. Second, after creating this, I want to create the table. The third query is create table. Create table. Again in HBase cell, what you'll write here. So let me go first and type here the create table statement. And I'll not use any. The cell was built on JRuby. This HBase cell, this query, whatever I'm running, this is built on Java plus Ruby concept. Now create table name, and table name I will give as demographic. You can give any table name, okay? These are just a name, logical name, demographic, comma, and yeah, by the way, if you want to create this table inside the namespace, then what you will say, your namespace name, then table name. Okay, if there we do use and then we start creating a table, automatically it goes inside your database. We don't have any use keyword here. We'd say while creating the table itself, you'll have to pass this. So syntax is clear. Your namespace colon your table name, and I want to store here personal data and professional data. I'm segregating this information. So this is personal, this is professional, and enter. Once you enter, then you can see this table is created. HBase table, HD demographic is created. Can I use a list command now? List command is a command. List is a command to check your table, just like show tables. Okay. So create table first we'll write create namespace name colon table name comma my demographic column family, right? Personal. This is a column family, personal and professional. The interesting factor here, runtime, I can create the column identifier and I can keep the column value there. Okay, in runtime. We're going to anyway see all that information. Now, fourth query is listing the table. Okay, check or show table. To show the table, we have command list and enter. Now we'll start inserting data. So insert here, this inserting I'll refer as put, so that you remember the query also. Put records in table. Put records in table. It's like HTTP call, put and get call. Right. Now I want to insert result in this table, which is HD for one person. Okay. Now suppose I have total result in my Excel or CSV file. Those results are 500 person data. 500% data I have. Okay. So all 500 are different person. All these 500 are different person. I want to store their data in NoSQL, and at the same time I want to store their data in SQL. I want to store their data in HBase and I want to store their data in SQL. If you want to do such experiment, you can definitely do that, right? And start running some query, especially DML queries like insert query or group by query. You can check the time, or how much time the system is taking and how much time the system is taking. This will take hardly a second. In fact, not even a second. Whatever query you're running, you can check this. Well, these are just a table creation. So this took me 1.4, 0.030. Currently, I'll try to create the same person data, but I'll not create one by one 500. I'll create 5. I have a bulk option also. Like if I want to store all 500 data directly into table, I can do that also. Bulk loading we call, right? In Hive, we have a load operation that does bulk loading. Here also, we can do that. There are several different approaches. We'll see all this point. Now, you will have to use put keyword to write the data, then table name. The important point here, I feel, uh, coming from typical traditional RDBMS background, here syntax is quite complex. So we'll have to remember the syntax only. Rest of the concept or the query part we can understand, but syntax sometimes tricky. Demographic, okay, and you want to create a column family. So personal, and I'll try to replicate this same thing here. I'm going to replicate this thing here. So personal has bank, credit, number, and pin code, right? Let's write this. First, per is my column family, column, bank name. Okay. I can do in a single column, I can do multiple entries also. But since we're doing first time, that's I'll do one by one. But if you're thinking why I'm doing one by one, do we have any option for multiple insert in a single row? We have that option also. Now here I will write the value of this bank, which is SBI. Write this. And remember, this is case sensitive. HBase is a, let me write that. It's a case sensitive. HBase is case sensitive. So if you write this B as small or capital, both will be treated separately. So please remember, SBI is the value and enter. We have some error, and what is that error? HD, okay, I did not define the row key. So I'll have to say row key R1. It should work now. So this result is associated with row number 1. Whenever I search for this result, okay, the first row result, always I'll search with this row key. Second, I want to store in this second column family, which is professional also. So per is done, and per is only done for banking. Now we have two more column identifier, C, num, and pin. I'll use this upper key. And since I'm storing for just one person result, which are associated with R1, I'll say credit number. And there we'll type 57. I'm taking some random value, 5702. Enter. Similarly, third, which is pin code, we write cross 9. First row key has data for first column family. Now second column family is pro. Let me check the name. It's a pro. And here we are storing the person name. This personal data belong to the person, and that is Abhi. So we'll write here ABHI. Then second is age, which I don't know, right? So no need to create an age here. You don't know that result. Simply ignore that. Give a second column identifier, which is city. Here I will write city. Indore and company name. Number, then company name. So far, I have stored this data. This result belongs to one row only, as in this is a data of one person only. Then similarly, second person data are, can I say this is R2, bank, and here I said I don't know the bank. This is missing, so I'll not give this bank name here, because since this is missing, no need to write it. You can directly go to C number, which is some number 5709. Then pin code 2x0. Then the person name. This is, if you see, I'm storing cell wise, right? This is like a cell data insertion, not insert into table name values and I pass all the value, because that was a row entry. This is a column entry. Name is, so this two result is done. Name is George. Then city, you know the city is Trichy, and you know their company. Which is TCS. Second person data entry is done. Third person data. This guy has all the result available. So I'll start getting from bank name. Bank name for R3, column identifier is bank, and this is city. Then credit card number for R3, and this number is 56231. Then company name. One second. Sorry, it will have pin code also before company name. Pin code is this 2x4. Then name. Now, if you're giving name, one name here in uppercase, n is uppercase, and suppose you give n there in lowercase, so both will be treated as a different column identifier. Okay, both are different column identifier. So you do not directly create a column here. You have the column family and then column identifier concept. The person name is J2, person age, and one second, we forgot to store the age for George. I can do that later also, not a problem. I'll do this in my last query. The person age is 32. First, I'll write all the data for R3 row. City is Pune, and company name. Uh, if you see, I have made a mistake. Um, I should write this name and other thing inside the proof column family. Okay. Anyway, I'll delete this result. To check the result, we can use a query scan, but for R2, R2 also is stored as for let me change this. So till this part is good. Okay, this result is not good. This should have here. I can do alter also, but currently I'm dropping this data. I'll say delete table name, demographic, column row key, and what data you want to delete. So let's say delete for all row R2, and what it is saying, the same command can also be run on the table conference. So delete cell value at a specified table. Okay, it's saying you have to specify the column family name in column identifier also. So per city, I want to delete this. Then I want to delete company. If you're getting me why I'm deleting, because entry I made mistake and wrong. Name is also name, city, company, and same thing for R2. Sorry, R3. R3 for name, for city, for age. And I want to scan the result first. So this is like a select a star from table name. Okay. So scan and my table name, which is HD underscore demographic. So scan is a select a star from table name. It will give you all the data which you have stored in this table. R1 we have this result bank. R1 is having C number also, PIN also. R1 is having prop city, prop company. R1 is all good. R2 per is good. Personal result is good. Credit card number, since bank is missing, that's not given here. Then PIN code is there. R3 bank, C name and PIN code. For R2, I'll say put, okay, or I can use my previous statement also. Put R2 and per is done. So this is proof. I'm matching it from here, okay. This 3 is a personal, this 3 is a personal, this 2 is personal because bank we don't have it. Professional, what is the column? Identifier name, starting with city, starting with city, comma city name. I will verify once again now. R2, C number, pin code, then name, then age, then company name. Okay. Can I scan it again just to check this result? So R2 is having C name, pen, age, city, company name. Now R3 is having data for all. So this query is already done. This last entry, R3, then R3 is having prof as starting with name. You can, by the way, give this any column identifier anytime. Okay, not necessary you have to follow some order. I can give name, then maybe you can give me company also, because data is entering in the cell, that right cell. Prof is age, which is 32. City name and company name. All data inserted. We'll verify this. So total how many results should be there according to this? Let me first count and then I will match there. One result, two, three, four, five, six, right? So six result should be there. Similarly, six result should be there. So 6 and 6, 12 plus here we have result in all the cell, all the column identifier, which is 7. So 6, 6, 12 plus 7, 19. I should have 19 rows here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Perfect. So all the result is there, whatever you wanted to store. This is how your data will look like when you type select the star from table name. Okay, because they stored in a vertical form, all the data. Now you're seeing there is one extra column your HBase cell is taking, which is a timestamp, right? This is a timestamp. So timestamp is there because when we want to update this, result, so there is one unique concept of versioning, which I will tell you later in this course. The concept name is a versioning concept, version maintain concept. So they maintain the version based on this timestamp. We'll see this version separately. So currently we'll prove uh, this 3 points with HDFS and RDFS. We're proving this point in HBase. We can do insert one by one. This is done. To insert this result, you have a keyword put, right? Then we'll see, can you update? Can you update? So we'll prove this 3 point, insert, update, and delete. Delete also we have seen, since I made some wrong entries, I have deleted random record also. This is also working. Now I'll do update. To update this, which result you want to update? Let's say you want to update the city for person 2. You want to change the city from Trichy to some other city. I want to change this result. How can I change this? The query is, again, you don't have any put thing here now, because if I want to update, I will update on the same row, which is R2, right? This is the row key, and again I'll use put. This is like overriding. Okay, if I say in object oriented terms, I'll say this is overriding. I am overriding on the same cell, which is R2. I'll give my table name, which is HD demographic, comma, your row key name. Now remember, as soon as you give this R2, immediately your focus should be there on this R2 row. When you type this R2, your focus is in this R2. Now, which column family you want to change? What is the column family of this 3G? Column family is prof, and column identifier name is city. Now, write this two thing immediately after R2. Prof colon city. Then what value you want to change? I will give this value name. This value name is, so I'm changing this to Bangalore. If I, and this timestamp must have changed now. You can check this, last is 834. If I type now for Bangalore, this has changed because timestamp is taking your system current date, and based on that, they're doing this entry. So update is also working. You have changed this result for row R2, and you can ask me to change anything here. I can use the same put keyword on this on the same row key where I want to change that result, column family, column identifier, and that result name. By the way, I can run this on cell. I can do this programmatically also. If I want to run this code from a Scala or Java and I want to access my HBase, I have that option. I have that POC written also. You'll see both the options. Now, insert, update, delete is done. But one more point is there. Can I do random reading? Because if I check in HDFS, all these options are not allowed. So that's what we said. All the limitation of HDFS is taken care by HBase. Here I can do random reading also. Random reading means you can pick any result from this table. You can pick any result, any company result, or any name, or any bank, or anything. Here this random reading is also not allowed. We have to scan the complete table. How to do this random reading part? This is a get method. So let me write in bracket. For insert also we have put. For update also we have put. Right? Random reading. Here we have get command. Now, say I want to check for person R1, row R1, what is the pin code of R1? Okay, let's say I want to run query on this. Now here it is not that select a star from table name where per is equal to pin. It's not like that. Here I'll say get my table name, my row key name. Suppose you want to check result for all the row. Okay, let's say you want this all result related to R1. You can type this. It will give you all first person complete data. That's what I'm saying. First person uh, is associated with R1. So in my previous example where I said I have total 500% data, right? So how many row key will be there? Total 500 row key will be there, because one row key you are associating with first person result. If you are associating this R1 with first person, then R2 is second person, and similarly if there are 500 result, there are 500 R500, and this is the last person. 500%. This is I'm doing, and data is entering in this spaces. So that's what I said. When I run my earlier queries, right, or I'm running that query currently, get R1, and I said I want to check for pin code. So get R1 per colon pin. That's it. Internally, what is happening? That's important. So when you run this query, what this query will do, let me go back to my table. Yeah. When I run that query and I'm searching for person R1 and I'm looking for this result, isn't it? So it will first go and check this row key. It will first go because it will read your query based on your order. So it will check the table name. It will check the row key, which is this. Then immediately it will check the column family, which is personal. And then say in personal, there are just one column identifier related with the name PIN. It will not check or scan this two column, unlike RDBMS. It will not even check this column family and none of this column identifier. It is only and only checking this PIN because this is what internally it is doing. It will run the query on this and bring me data which are matching with R1 in my console. And this is what is the output. If you see the time, guys, my unit of time is microsecond, not even millisecond. It's microsecond. Okay. So since this is just one CPU, but you can imagine in the case if I have multiple machine and multiple CPU, that is the reason your HBase is running or your Facebook is running 1 billion query. Now this looking at this concept, I can accept I can accept this statistics which says 1 billion query we're running on every second. If somebody says me this that we are doing this in RDBMS, I cannot believe that. I need to know the answer or maybe the log file or the statistics. But if somebody says me and I'm working with HBase or Cassandra, looking at this one query is taking me this much time, I can say yes, this is quite a lot possible in a concept of low latency. So let's see the question. Where clause is not possible? I guess it is possible. Where clause is we do not have the where query, by the way. We don't have this where query, but we have the filter. Okay, so once we complete this HBase thing, okay, it will take a day or so. So once we complete this, then you can ask me that I want to get this result or that result. All that operation can be done by this filter. And by the way, that command is it filters something or show filters. One second, let me see. Show filters. Yeah, show filters. So this is all the filters. This is like your where query, where clause. So you can put, uh, I get the point. You're saying that you want to search result from, let's say, person who are having age of 29 to 35, people who are having salary more than $1,000, right? People who belong to city called Pune only. You can do all this query using this filter operation. Okay, this filter concept will come once we know the basic part of this, which is insert, update, delete, and random reading, which is get. This four operation we have seen. We know how to create the namespace, how to use the namespace, how to create the table, how to list it. Basic thing is done. You cannot directly, last two query for today, you cannot directly delete this result from your table. Okay, we'll have to first disable the table. Why the query is faster? If you ask me, the query is faster because this data, whatever data I have inserted, right? Whatever data I have inserted in this table, this is getting stored where? This data is going to your HDFS only in the main space of HDFS. If I go to HDFS and run a query, HDFS dfs-ls/hbase. So this will give me all the subfolder or file inside this HBase. Now my query is ls. I want to check recursively. Okay, where is your data entry? Now your data entry must be inside. Let me see this result. Okay, now this is for namespace, by the way. This is for namespace. This is having your namespace entry. Your data entry is there, guys. This is the per and prof folder. You can see it here, per and prof. If I go to per, copy and give this full location of per. One second. We have any per folder here. So I'll copy it here. I'll paste it here. Enter. Okay, so data we don't have inside per pro. This is just giving me the column family name. Data may be somewhere here. This is directory. This is the. I need to check actually. I need to check one by one. Then I can get. I don't remember. This is a complex name, so don't remember the exact name. We'll have to check one by one. We don't have here also. Edit sequence ID, default HBase meta table description, reason booking. Can I see this? 24th May we have this top result only. 20 according to the system, the date is taking 24th May. Let me see this file. The size is big. XDFS, DFS, hyphen cat. Mem store time is string. Data is in a serialized format. Okay, so I cannot read the data, but yeah, these are the information. These are your information which you're storing in your table. Some data still, if I check every file, so I'll take that as a part of your assignment. Check for all the file, their directory location. Go for all the file and check. Start seeing this. You can see the answer where which folder there is storing the data, but it is going in the serialized format. That is the reason this is looking me in a form of sequence or binary. To last query, if I want to delete the drop the table, I cannot directly drop it. Okay, if you want to drop the table, you cannot directly drop it, because if you try to do this, and actually we should try with this demographic, it does not allow me. It says me disable the table first and then drop it. It says me disable the table first and then drop it. So I'll continue from here uh, tomorrow, why we have to disable it first, and why this query is faster. Disable means, are they caching any information? Are they caching the data? We'll see this other parts.